Hello friend, welcome to Marine Engineering Hub. This is your narrator, Chief Engineer Ravi Gupta. Today we'll talk about what things we need to take care when we are entering into a dry dock. So before entering into dry dock, what thing we need to take care in today's video we'll talk about. The first thing is like that stability of vessel. The second, after that we'll talk about critical period in a dry dock, and then we will see how the trim and draft affect before entering a dry dock, and then we'll see what preparation you should need to do when you are entering into a dry dock. After that we will see that how the and what should be the condition of a load distribution of your ship before entering a dry dock, and then when you are docking, when you are entering a dock, at that time what should be the condition of your machinery and what safety precautions you should take. And after that we will see how the docking master coordinate all the docking operations so that the ship can be docked properly in a dry dock. So friend, this video is going to be interesting. After watching the video you will have a complete knowledge of what is a critical period, how the critical period affect the docking, and what action you should take before entering the dry dock, and what should you do while dry docking. This is a detailed video, and if you want a precise video you can watch the part 3, and if you want a detailed explanation for your concept you can watch this video. So let's start the today video of things which we need to do before docking. Before starting the video, I want to tell you, those who are watching the video first time, that Marine Engineering Hub is a platform where we make video which will be beneficial for examination, interview and for oral. So please do subscribe and please do share our video with your friends and colleagues. Your one subscription give us a lot of encouragement. Friend, those who are right now giving MU class 1, class 4, class 2, I request to all of you, please join our channel. There are a lot of video in the channel which are yet to be released, which will be beneficial for your examination. I am making the video in such a way that it look presentable and it will be beneficial for your examination purpose, so that you can just go through and can speak in the examination on oral and can write in the examination. So please join our channel. So let's start today's video of the first, what thing you need to do before entering a dry dock. The first question comes to our mind that when you are trying to enter a dry dock, you want your ship to be in a upright condition like this. Means when you want to enter in a dry dock, at that time you want to enter in a upright condition. In order to be in an upright condition, the main thing which come in effect is that is the stability of the vessel. So how to ensure that your vessel is properly stable? So in order to have a stable vessel, you need to have adequate metacentric height. What is metacentric height? Metacentric height is the distance between G and M. It means that the metacentric height is the distance between G and M, and is considered a positive metacentric height when the G is above M. When G is above M. And why we need this positive metacentric height? As you all know that this positive metacentric height is responsible for producing the righting moment GZ. This GZ is being produced when the metacentric height is positive. This righting moment help to bring back the ship back to the upright condition when it is heel to one direction because of wind or waves. It means that if your ship is in upright condition and after because of any wind, if it get heel in only one direction, it will bring back to the upright condition by the help of this GZ, which produce the righting moment. Now this GZ will be only be produced when the metacentric height is positive. So therefore before entering a dry dock, you should ensure that you should have a sufficient amount of metacentric height. Now if you have insufficient metacentric height, then what will happen? You will have a excessive heeling, and which will cause the ship to lean in one direction and it may causes the capsization of the ship like this. It means that you want to enter a dry dock in this condition, not in this condition. If you enter in this condition, your ship may capsize like this in a dock, which you don't want. So the most important thing before entering a dry dock is the stability. You have to ensure that you should have a sufficient initial metacentric height. The second is the vessel to be in a upright condition. Now when you are entering a dry dock, you want to enter in a upright condition, means you are maintaining sufficient amount of initial GM as a backup, so that if any heel is there, you can come back to the upright condition. But when you are going inside a dock, you want to land properly like this in a upright condition. You want to land in a upright condition, because if you land in slightly slant way, it may cause the ship to capsize. So in order to ensure that even landing, you will enter in an upright condition to ensure even landing on a keel block. How? Like this. Means in a keel block you want to land upright condition in a proper way, not in a slant condition. So the two things as per the stability is that first is the adequate initial GM, and second is the vessel to be in a upright condition. Now the second question come is that when you are landing in a dry dock, how will you land? So basically it is told that you need to maintain sufficient amount of trim. You need to maintain sufficient amount of trim, but trim should be only sufficient amount, means that is a very slightly amount. So what is the trim? So basically trim is the distance between the forward draft and the aft draft. The forward draft is 10.32 and aft draft is 12.40. So difference between that two will give you the trim. So when you are entering a dry dock, you are entering with a slight trim. Now why we want to enter in a dry dock in a slight trim? We want to enter in a dry dock in a slight trim so that the stern part of a vessel settle first on the block, followed by ensuring that proper alignment and stability. So if anybody asks you that why the ship stern part is first made to sit in the keel block which are laid in a dry dock, the answer is that it is made to sit in the stern part of the keel block first, is that because it ensures proper alignment and stability. So along with that, the second question comes is that what and how the ship is made to sit in a dry dock. So this is a keel block. The keel block basically look like this. If you go, the keel block basically look like this. You can see the keel block like this here, and if you want to see more, it basically look like this. The keel block is laid like this, and after that the ship is made to sit by the stern point touching the first ship. So now one question which I basically asked in examination MU class 2 is that what do you mean by critical period in dry dock, and which period is the critical period in dry dock? My question can be asked from there. So first answer is that the time period when the stern part of a ship first touches the keel block, at that point is called critical period. It means that when the stern part just touches the keel block, at that period is called critical period. Now the second question comes, why it is called critical period? It is called critical period because when the stern part of a ship touches the keel block, at that time an upthrust is being created because a part of a weight of a ship is being shared by the keel block. It means that when the stern part of a ship is touching the keel block, at that time some weight of a ship is being taken by the keel block, and hence it create a upthrust which is called P. This P have a effect of reducing the initial metacentric height and hence threatening the stability. Now I have told you the answer that what is happening. Now how it is happening, we will see here. So what is happening? First I have told you that we should have a metacentric height GM, positive metacentric height. Why? Because it is producing a righting moment to bring back ship the upper direction. Now come to the critical period. Here what is happening? The keel block is, the stern part of the ship is touching the keel block. At that time what is happening? A part of a ship weight is being taken up by the keel block, so it produces a upthrust P in a upward direction. So before, the center of gravity was here, okay, it is acting in a downward direction. Now because a part of weight is being taken up from by the P, so G shifted to point G1. So before, the righting moment which was generated when it was not touching the keel block was GZ here, but now is generating G1Z. So you can see the righting moment GZ compared to the G1Z is more. It means that when the ship was not touching the keel block, at that time the righting moment was more, that if anything happen, ship will bring back upright condition fast. But as soon as the ship touches the keel block, its righting moment reduced, and now it is this much. So now the ship will not able to bring back in upright condition very fast. So initially it means that when the ship touches the keel block, at that time the initial metacentric height is getting reduced, and hence it is threatening the stability of a ship, and therefore this period is called critical period. So in examination you have to explain like this. So what is happening? The first, the stern part of a ship is touching the keel block, and slowly the water is being pumped out, and the whole part, front part, is getting sit in the keel block like this. But why we are making sit the stern part first? Because to ensure proper alignment and stability. Now why this period is called critical period? This period is called critical period because a part of a ship weight is borne by the keel block, and while doing so, what is happening? It is creating a upthrust. That upthrust is basically reducing the metacentric height. Now reducing the metacentric height is what is happening. Reducing the metacentric height is threatening the righting moment, and hence threatening the stability of a ship. How it is threatening the stability of a ship? Because the part of weight is borne by the keel block, the center of gravity is shifting from G to G1, and hence the righting moment before, which was GZ, is reducing to G1Z, causing reduction in the righting moment and stability. So you should have an answer like this. Now let's go to second part. Now I have told you the importance of trim. Now the second thing come about the draft limitation. How the draft is important? So basically, what is draft? It is like a marking which is made in a forward and same in a aft. Based on this marking, trim is being calculated. Now it is very important to ensure that ship draft is compatible with the dry dock depth. If it doesn't happen, what will happen? It may happen that vessel touches the dock prematurely. So it is very important to ensure the draft. So till now what we have learned? We have learned that how the stability of vessel is important, what is critical period, and how trim and draft affect. Now we come to third part, is that how you are gonna prepare for a dry dock. So first thing in a dry dock we'll do is that block arrangement. So you can see this is the keel block which has been placed in a dock in before the vessel is coming inside. So before the vessel will come inside, you have to place the keel block as per the docking plan. So the first comes the block arrangement. So the block arrangement, keel block arrangement should be done in a proper way. In a proper way means that the block should be correctly positioned, and it should be correctly positioned means what? That it should be adequately spaced. Now this two is very important thing. So why it is very important? It is very important that you should understand. Suppose this is a ship bottom part. Now you have placed one keel block here and you have placed one keel block here, but as per docking plan you should place in between 3 keel block, but you have placed 2. So what will happen? The due to the less placement of the keel block, the weight will get here, sagging of a bottom structure will happen. The sagging of the bottom structure will happen. Now suppose you have done what? Now suppose you have placed, instead of you have placed, suppose you are supposed to place 3 keel block and you have placed 4 keel block. Is it advisable? No, because then what will happen? The hogging of the structure will happen. So it is very important to ensure that you place adequately keel block in a correct position. Now how you will determine the correct position? You will determine the correct position by docking plan. So in the examination, if they ask you that how this keel block, this block is been placed in a dock before the ship is coming inside, how you know that where to place? So this you can know by docking plan. So what is a docking plan? Docking plan is a plan which has been given by the shipyard during the delivery of ship. At that time it has been told that where the block is need to be placed, so that when you are bringing a ship inside for dry dock, at that time it is in a upright condition like this. It is in a upright condition is like this, and the weight of the ship, is properly equally been shared. So that is the importance of having vessel docking plan. So the docking plan should be come handy, which give us the insight that where to place the keel block. Now the keel block should be in a good condition because it is gonna take the ship weight. Now the second most important thing is the dock gate integrity. It means that okay, you are taking the ship inside, and after that your dock gate, this is your dock gate, it should be such that after ship come inside, you start pumping water, there should not be seepage of water from here after the water has been pumped. It means the dock gate should properly get tightened and it should hold. It should be water tight without any leakage. The third thing is the condition of a flooring of a dry dock. It means that the dry dock floor should be free of debris, free of material, and it should not have any crack. Means it should not have any crack which causes the water to come gushing in if it is a floating dock, or any leakage from the from bottom, or too much material and debris which can harm the work. So it should be also be clean. So it's very important that your floor is clean, you are free of debris, and there should be no crack that can compromise the operation. So now you have first take care of the stability, second you now know critical period, and now you are preparing for dry dock. So when preparing for dry dock, you contact the vessel docking plan. Based on the vessel docking plan, you are placing the keel block, and while placing the keel block, you are also checking your dock gate. This dock gate, you are checking whether it is properly watertight or not, and third, you are checking your floor to ensure that your floor is free of debris and clean, and which is not hamper the operation. After that, now you are bringing a ship inside. Now before bringing the ship inside, you have to ensure that your ship should not contain any cargo. Now when your ship is sailing, it is full of cargo, but before entering the dock, your ship should be in a light condition. So what is light condition? It means that it should not contain any unnecessary thing which can cause increasing of weight. So your cargo should be removed as much as possible, and it should be in a light condition. The second thing is the ballast. Now before I have told you that you have to maintain proper trim. Now this trim how you are going to maintain. So sometimes they ask a question in the examination that how much ballast you will take when you are entering a dock, whether you will go full ballast, whether you will go zero ballast, what? The answer is neither of that. you have to take adequate quantity of ballast that will be sufficient for maintaining the trim which is been required by the docking master. One more time I will tell you. Now the docking master want the ship to be inside a dock like this. So what he want? He want the ship to be trimmed by stern. Why? Because I have told you for proper alignment and stability. Now we also need a trim because we want to sit the stern part first. Now this trim is been maintained by how? This trim is been maintained by ballast. So by filling the ballast tank, you are maintaining slightly trim by aft 0.5 to 0.1. So you have to take some ballast in the ship in order to ensure that your ballast is sufficient amount enough to maintain the trim which is required by the docking master for dry dock. So now you know how you should be load distribution during ballast. Now we gonna talk about masonry. So as you know that when you are entering a dock, at that time you should be very much careful that your propeller and rudder doesn't get harmed. So how you will do that? In order to ensure that this is possible, is only been possible that you don't operate it. So when we are entering a dock, we stop the propeller and rudder and keep it midship, and we don't use the engine and we use a tugboat to get inside the dock. Now it means that the propeller will be stopped, rudder will be centered, center mid is midship, and to avoid damage while landing on the block. Second is that the machine will be shut down, it will be, and the auxiliary will be secured, and the ship will be ready for dry dock operation. Safety precaution. Now one thing I want to tell you here, as I told you before, that the propeller and rudder will be not be used so that it can be properly aligned and it doesn't get damaged when we are entering a dock and when we are setting the stern part first. So as you can see that here, as per docking plan, it is been told where to place the dock. Now this part of a ship has containing some weight, but you are not placing any keel block here. Okay, so how this part weight is been distributed? So in order to ensure that this part of a weight of a ship is been distributed properly, you are putting additional keel block so that even weight distribution can happen. One more time I will tell you, in order to avoid damage to the rudder and propeller, we are not placing keel block beneath that, but the weight on the top and the rudder and propeller need to be distributed evenly, so we are placing more amount of keel block on the stern part of a ship so that weight can be distributed properly. So as I before told you, therefore we are ensuring this. Now when the ship has been docked, at that time, in order to ensure that the safety doesn't get compromised, it is always been kept operational also during the dry dock process. It means that in the dry dock, the safety firefighting system will always be operational so that if any mishap occur, you can still fight the fire. Now let's talk about the docking plan. So the docking master is responsible for ensuring that the ship is properly been docked, but he cannot do alone. He need the help of a dock crew, he need the help of a shipping crew while doing the docking. So how he will do? So he will first specify the block placement, he will specify the trim, and he will specify the sequence of operation. So what do I mean by sequence of operation? It means that the first docking master will come and he will come here with the captain and with the dock crew. The three party will sit together and they will discuss whole operation, that we are gonna enter in a dry dock like this, with this amount of trim, with this amount of ballast, and once we enter and stern part touches, we will pass the rope, and when we will pass the rope, you have to tighten it in a proper sequence way so that the ship remain in the upright condition, and the tightening procedure will be guided by the docking master by as per seeing the situation. The whole thing is a clear communication channel need to be established in between the three party in order to ensure that the docking operation is carried out successfully. So the docking master will come, he will first see the docking plan, he will see the as per docking plan he will first place the keel block, and after placing the keel block he will now tell the master to maintain that amount of trim before entering a dock. He will inform the dock crew that when they start to pass the rope as per his instruction, start to tighten it. So that whole thing depend upon the clear communication channel discussed before and on which channel they will be corresponding. Now the third question comes is that if suppose during a dry dock, if the weather become bad, will you still carry out the operation? The answer is no, because as you can see that dry dock doing a docking a ship is a very critical operation. So in order to avoid any further criticality, what we are doing, we are avoiding any strong type of wind and current if doing a dry dock. So what we are doing, suppose if the weather get bad and if the sea got rough, in that case we will not do the dry dock because it may happen that it may capsize the ship. To prevent that, we will avoid complication if there is strong weather, wind or rain. So friend, in today's video, if in synopsis we tell, so what we have learned, the first thing we have learned is that how the stability of a ship threaten the dry dock. So first we need to maintain adequate GM and vessel to be upright condition. After doing that, we have to land the stern part first by maintaining the adequate trim and draft, and as the stern part is landed, at that time we need to ensure that ships should have a sufficient GM because this is a critical period. After critical period is over, what we will do now, when we are entering a dock, we need to ensure that the block is properly arranged, because if not properly arranged and adequately placed, it may cause the hogging and sagging and may threaten the ship stability. Now the dock gate which we are using, suppose if we are using graving type of dock, the dock gate should be proper so that this should not be water leakage from the dock gate. The dock floor should also be proper, free of debris, free of any type of materials which can hamper the ship operation. Now after that we learn that how the load distribution of ship is useful when we are doing to dry dock, means how the load distribution we are going to do when before entering a dry dock, means it means that ballast condition need to be maintained as per the trim, and load cargo should be removed, unnecessary cargo should be removed because it will hamper the ship stability. So after that we have learned that what action we should take when we are going inside a dock. Propeller and rudder should be stopped in a midship condition. After that main engine will be stopped, auxiliary engine will be secured, and ship safety will be continuously be used during the operation. And after that we know now that whole operation will be carried by the docking master as supervising with the help of a communication between the dock crew and the ship crew. So friend, if you have learned something in this video, then please do like and please do subscribe. If you are watching the video till now, I know that you want to pass exam, so please join the channel. Very minimal fees, which is very minimal, so please join and